what I want to point out now, so as you might start to guess, when we start to pile up all of these orbitals on top of each other, and in other words, when we get to the complicated atoms, the atoms that have 4f or 3d electrons, okay, they start interfering with each other, and we call that interference penetration. So I'll write interference, okay? So in other words, the electrons are getting really close to each other, right? You can see the 3d, the 3p, and the 3s. They're all like predicted to have similar distances from the nucleus. So that means because they interfere with each other, they cause the levels to split, all right? And the order goes S, P, D, F, just like we learned from the quantum number rules, okay? And in a moment, I'm going to show you a fantastic way to remember this order. You don't have to memorize it as long as you can remember it. And where we're going next, I'm going to give a little foreshadowing to where we're going next, which will be a next video. But now when we get into these orbital energy level diagrams, because all these orbitals get complicated, we have to have a more simplified way of representing them. And we do that with these diagrams. So these diagrams are our simplified way of representing these complicated polyelectronic atoms. So atoms containing more than one electron. So we started with this, with our basic energy level diagram, 1, 2, 3, and 4. Okay? And for hydrogen and hydrogen only, when we put the orbital designations on, this is what happens. Look, n is equal to 1 becomes 1s. But look, n is equal to 2, it has 2s and 2p. And for hydrogen and hydrogen only, 2s and 2p are degenerate, which means it's a fancy way of saying the same. It means they have the same energy, okay? And we notice what happens to n is equal to 3 for hydrogen and hydrogen only. 3s, 3p, and 3d are all predicted to be at the same level. Same with 4, 4s, 4p, 4d, 4f. They're all predicted to be the same. However, as soon as we put multiple electrons in there, those levels interfere with each other and they cause them to split. Because, for one, electrons repel other electrons. That's the particle interaction. But electrons also interfere with other electrons. That's the wave interaction. And this order becomes S is less than P, which is less than D, which is less than F. So now what happens in these levels, we start at 1s, and then, right, going up in energy gives us the correct order. So we start at 1s, and remember, we still call this the ground state, or the ground level, okay? 1s, 2s, and then now look, 2s and 2p are no longer equal. 2p is slightly higher than 2s, okay? So it splits. And then now, we know that level 3 has to be higher than level 2, okay? So 3s is higher than 2p. But now look, 3p becomes higher than 3s. And this is where it becomes a mess. Because now, as it turns out, you would expect that 3d would be next. But as it turns out, 4s is slightly lower in energy than 3d. So then it goes 1s, 2s, 2p, 3s, 3p, 4s, then 3d, then 4p, then 5s, then 4d. It becomes a mess. And in fact, here is the full periodic table right here. So this is the full table. And as you might guess, like, look, so this is showing you in order, right? 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d. So how do we keep track of that order? Well, I'm going to back up for a second and go back to our periodic table. Okay, this. Quantum numbers are the address of an electron on the periodic table. So the way we remember that order is by starting here with hydrogen. We start here and we move from left to right, top to bottom. Okay? Left to right, top to bottom. And then check it out. So this order goes 1s to start, okay? and then next is 2s, and then look, next is 2p, and then next is 3s, and then we keep scanning across, and then 3p, and then 4s, and then now look, it goes 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. We can literally go left to right, top to bottom, and that is the correct order for these energy level diagrams right here, okay? So this complicated mess of order, it's just unraveling the periodic table. So instead of looking at the periodic table from left to right, top to bottom, this just starts with an energy level diagram of every single position on the periodic table, and that's what we're going to see in the next lecture. Each one of these spaces represents a position on the table, okay? And we're going to go through this. We're going to do this outbound principle. Electrons are added one at a time to each successive orbital in order of energy. We're going to go through it and do it on the next video. Okay, folks? Hasta luego.